In this module, we'll discuss about fast Fourier transform and we'll implement this fast Fourier transform on DSP development board. Fast Fourier transform is an efficient algorithm used to compute discrete Fourier transform mathematical procedure, much faster than the DFT itself. Instead of directly evaluating the DFT, which takes n square operations, the FFT reduces the complexity to n log of n by exploiting symmetry and periodicity in the computation. So FFT speeds up the calculation by dividing the sequences into smaller parts, reusing the computation and combining the results very efficiently. So this algorithm for implementation of FFT involves, first we divide the sequence into two parts, even index sequence separately, odd index sequences separately. And this procedure of decomposition continues. So we express DFT as two smaller DFTs. Each decomposed sequence DFT is calculated. Now this procedure for recursively decomposition continues till the length of the sequence becomes 2, and then it combines the results step by step. In a summary, FFT is the fast method to compute DSP. It uses divide and conquer technology. Core idea is split, compute and combine. Highly efficient and widely used in real-time system applications.
This is DSP board TMS320C6748 connected to emulator XDS-V3, and now this emulator is connected to PC. Now let's execute the program.
Estimation in time fast Fourier transform algorithm on DSP development board. In this program, first we initialize the variables. After that, we ask the user to enter the values of x of n, and then we perform FFT calculations for n equal to 4 and n equal to 8 separately, depending on the length of x of n. After the results are obtained, we also calculate inverse FFT process to verify whether results are correct or not. Let's now execute this code. First, build finish. Now debug. Now execute the code. Enter the length of x of n, 4. 1, 2, 3, 4. These are values of x of n. And we get the result x of k equal to 10 minus 2 plus 2j minus 2 minus 2 minus 2j. And inverse result 1, 2, 3, 4. This entire program is executed over DSP development board as it is connected to the system. And this complete demonstration of FFT and inverse FFT on DSP development board. Algorithm to find linear convolution using FFT. First, we need to select n. To find linear convolution, n has to be greater than or equal to L plus m minus 1, where L is the length of first signal and m is the length of second signal. To find linear convolution using FFT, we require the length of both the signal exactly same. So by appending signal by zeros, appropriate number of zeros, we get the length of both the signal exactly same. And then we find y of n, that is linear convolution of x of n using h of n by FFT algorithm. So this is 4-step procedure. First step, we have to find FFT of x of n, we get x of k. Then we find FFT of h of n, that we get x of k. Then we multiply x of a with h of k, 1-to-1 values, we get resultant y of k, and by inverse FFT we get required y of n. Similarly, we can find circular convolution using FFT. To find circular convolution using FFT, we have to select n equal to maximum out of L and M, where L is the length of first signal and M is the length of second signal. Then we have to make the zero padding to both the signals so that length of both the signal will become n. Then we have to find circular convolution using FFT. First we have to find x of k, then we have to find h of k, we have to multiply x of k with h of k, we'll get y of k, and by inverse FFT we get required y of n. This y of n is circular convolution of x of n with h of n.